Today we are talking about two new theorems, Rolle's theorem and the mean value theorem. Okay, I mentioned to you the other day that we now have three value theorems out there. We have the intermediate value theorem, the extreme value theorem, and the mean value theorem today. Now, let's talk about these for a minute. First of all, what does the word mean in mathematics? Average. And it's going to have something to do with the theorem when we get there. Let's go back for a minute. The first one we learned was the intermediate value theorem. And intermediate means somewhere in the middle. Intermediate school is like middle school. Some districts call it that. The intermediate value theorem said if you have a point down here and a point up here, it's going to hit every y value in the middle. Okay? That's the intermediate value theorem. The extreme value theorem is the extremes are like the highest and the lowest you can go. If you've got a continuous curve, you're going to have a definite highest point and a definite lowest point. That's what the extreme value theorem says. Today is going to be the mean value theorem. Okay? You've got to be able to keep the three of them straight. We're going to start with Rolle's theorem. It's rather simple to do. It is named after a French mathematician named Michel Rolle. Michel is Michael in French, for those of you who don't know. Sounds like a girl's name. No, he's not a girl. It's a guy. The ironic thing was I read something not too long ago that he was very, very anti-calculus when Isaac Newton and Leibniz were coming up with all these calculus formulas. And now one of his theorems is part of calculus curriculum, even though he was anti-calculus, which I thought was rather ironic. Okay? So I'm going to go through this very slowly. We're going to stop at different points and talk about what's going on. Let f be a function that is continuous on bracket a comma b, bracket, that's a closed interval from a to b. Now that's usually been the starting sentence for every theorem we've done so far. Let it be continuous on a to b. But this one has more. And differentiable on parentheses a comma b parentheses, period. Let f be a function that is continuous on the closed interval from a to b and differentiable on the open interval from a to b. Okay? What does differentiable mean again? You can take the derivative. Okay? So these two criteria, continuous and differentiable, are very important. Please underline them in the theorem. Because as you do these problems, you have to check and make sure that the function fits into both of those. That it is continuous on the closed interval, no holes, no asymptotes, etc. And that it's differentiable, or it has a derivative, on the open interval. What kinds of graphs don't have derivatives? Graphs that have what? Cusps or corners or asymptotes or vertical tangents or things like that. Okay? So why do they say open interval? Because if you have a graph with endpoints, do you really know what the slope of the tangent line would be at the endpoint? No. That's why we don't include the endpoints for the differentiable. Okay? So here are two criteria. There's actually a third, and it's embedded in the next sentence. And it says if f of a equals f of b, comma. What does that really mean? F of a equals f of b. They have the same y. When you have an a and a b, they have the same y value. Is that what that says? Yes. So that is the third criteria. It has to be continuous, it has to be differentiable, and the y values at a and b have to be the same number. Okay? If all three of those happen, Rolle's theorem will apply. And Rolle's theorem says, then there exists at least one C between A and B such that f prime of C equals 0. Okay. If all three criteria are met, there will be a point somewhere in the middle where f prime of C is equal to 0. Can somebody tell me another way of saying what that is, or do you have a question? To answer my question, yes. There will be a maximum or a minimum, yes. Or what kind of a tangent line occurs when f prime is equal to 0? Horizontal, right? So this is saying that if all three of these happen, there will definitely be a point in there where the derivative is 0, where there is a max or min, where there is a horizontal tangent. Okay, let's draw a picture of this. Do this on this side. Go ahead and draw a first quadrant. Put your A and your B in there. We have to draw it according to what the setup says. So basically we're giving a picture representation of any possible way to do this. I'm going to have to draw something continuous. I'll take care of that in a minute. Differentiable, I'll take care of that in a minute. But f of A has to be f of B. So in other words, the two dots that I draw have to be the same height. Definitely. Those have to be the same height. They can be low, high, I don't care where. Okay. Continuous. Well, let's remember what continuous means. When it's talking about a graph, it's a graph that is smooth. It has no holes, no asymptotes. It's just smooth. You can draw it without lifting your pencil. Okay? Now, differentiable means no corners, no cusps, no asymptotes. Okay? So I want you to, between your two dots, draw a piece of graph that fits that criteria. Has to be smooth, no corners, no cusps. So go ahead and just sketch something in there. I don't care what it is. Make sure it's a function, though. It has to pass the vertical line test. Okay? Now, I'm going to be creative. We got some creative ones? How many of you just went like that, straight across? Be honest. Okay, that's fine. That's fine. Straight across. I'm in a little bit of a curlicue mood today, just try to make it a little bit different. Okay. Do you see on my graph at least one C place between the A and the B where the derivative will be 0? Do you see at least one? How many do you see? I see 4. Okay? On your graph, whatever it looks like, I want you to draw in a little dotted tangent line where those C values are. If you drew a straight across line, the entire line is a C value. All of them are C values. So C, 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 and C. Does everybody have at least one?
So if it's at your endpoint?
No, it doesn't count if it's at the endpoint, because it has to be between A and B. Okay. So do you agree that no matter how I drew this thing, I would get at least one point in there where the derivative was 0? There's just no way it's not going to happen. Okay. That's Rolle's theorem. Okay? So what you're going to be given on the worksheet is some problems where you have to check and see if it fits the criteria and then actually find where the C value is without a picture. Okay? So let me show you. For example, f of x is equal to 4x minus x squared on the interval from 1 to 3. F of x equals 4x minus x squared on the interval from 1 to 3. First thing you're going to do is check if Rolle's theorem applies. So the 3 things that I underlined in the theorem are the 3 things I got to check. Okay. Number 1, is it continuous? Well, without a picture, that's a little hard to tell. So let's talk about that. How can you tell without a picture if it's continuous? Okay. Does anybody have a guess as to yes or no, and tell me why you think it's continuous? Chris?
It's not grading. Like there's no X on the bottom.
There's no X's on the bottom. That would cause an asymptote. So that's a good thing. What else do you see that would make it continuous? Does anybody have something else to add? Say it again. It's quadratic. Exactly. Quadratics are smooth curves, aren't they? Now, Can something have a sharp corner and still be continuous? Yes. An absolute value graph is continuous, but it's not differentiable. Do you follow what I'm saying? All these terms are starting to come together, and you've got to understand what it's saying. Quadratics are always continuous. Okay? That's another way to tell. And because there's no denominator where there might be a hole or an asymptote, I'm good as well. So all I'm going to do, check. It's continuous. And you may want to write out to the side why we came up with that, so you have it to refer back to. It is quadratic, and there is no denominator. Okay? Because when you go back and look at your notes and you say continuous, why did I say it was continuous? That means nothing, especially for the people who aren't here and able to see this. Okay? Now, here is the next one I want to talk about. Differentiable. Question mark. This is not quite as easy to see. Okay? I've been talking about differentiability in the last 3 days and not calling it that. Okay? Let me tell you a sentence describing what I have been saying and connecting it to previous knowledge. A function is differentiable, derivative does not fail. Let me say that again. A function is differentiable if its derivative does not fail. Does that make sense to you? Okay. So think about what we've been doing with the maxes and mins. Does this have a derivative? I haven't taken the derivative yet, but will its derivative fail? No, because there is no x's in the denominator. Do you follow what I'm saying? Okay. Even though I haven't taken the derivative yet, I know that this derivative will not fail because there will not be any x's in the denominator. So this graph is differentiable. You follow what I'm saying? Okay. So differentiable, check. The derivative will not fail. Now I'm going to put a little disclaimer on it, on the interval. Because, the reason I say that, you may come up with a problem where if the interval is from 1 to 3 and the derivative fails at 0, is that graph going to be differentiable? Yes, because that 0 is outside the interval. You follow what I'm saying? All I'm wondering is it differentiable from 1 to 3? And this one's differentiable everywhere, so we're good. But you've got to talk about on the interval. It only can be on the interval. Okay, so continuous, we're good. Differentiable, we're good. Third one, f of 1. Does f of 1 equal f of 3? F of a equal f of b? We've got to check and see. Okay, f means we plug it into which function? The original or the derivative? Original. So when you plug 1 into the original, what do you get? 3. Okay? When you plug 3 into the original, 4 times 3 is 12, minus 3 squared is 9. 12 minus 9 is 3. Are they the same? Check. That one's easy to do. Just do the math. Okay. So, if all 3 of them are yeses, then you can go and find the C. If one of those came out to be a no, you would just write Rolle's theorem does not apply, and you're done. That's all you do. Okay? And it's going to happen, possibly on the worksheet, yes. Where you do continuous, check. Differentiable, oh, no, there's a sharp corner here, therefore Rolle's theorem doesn't apply, and you're done. You just stop. Okay? So now, according to the theorem, it says if all 3 of these are yeses, there will be one C where the derivative is equal to 0. So, that means I need to take the derivative and I need to set it equal to 0. So, take the derivative here. What's the derivative of this equation? Negative 2x. I'm going to write it the other way. 4 minus 2x. And it says the derivative is guaranteed to equal 0 somewhere between 1 and 3. Let's solve for x. 4 equals 2x, x equals 2. Now, it says C. I did this in terms of x because the x value will only be a C value if it falls between these two numbers. Does this number fall between these two numbers? Yes. So my final answer is C equals 2, and I'm done. Okay? Now let's talk about a couple of what-ifs. Is it possible on some problems if you take the derivative and set it equal to 0, you get more than one answer? That's possible. Okay? It is possible that when you do that, one of the answers will be on the interval and one of them will not. If that occurs, the only one that is considered a C value is the one that's on the interval. Does that make sense? You just throw the other one away. Okay? Someone last period asked me, well, what happens if you take the derivative, set it equal to 0, you only get one answer, and it's not on the interval? Well, Rolle's theorem says you are guaranteed that you will get an answer that's on the interval, which means you must have made a mathematical error. Okay? So if you do the math, you only get one answer, it's not on the interval, you messed up. You follow what I'm saying? Okay? So, is it possible to get more than one C? What do you think? Did I have more than one C in my picture? Yes. So it is possible to get multiple C's. You could get like 3 answers and all 3 of them are good. Okay? Questions? All right. Let's move on to the mean value theorem. Does anybody else think about it? I kind of jump on ahead. Anybody have any questions? Maybe I'm explaining it really good this period. I don't know. Yes, ma'am. Could it be an endpoint? Is that what you're asking me? It says in the theorem that C has to be between A and B, not including A and B. That's a good question she just asked. She said, is it possible that you do the math here and you get X equals one of the endpoints? It's no, because it says that C has to be between A and B, not equal to A and B. Okay? So if it's an endpoint, you actually do throw it out. Okay? Any other questions? All right, let's move on to the mean value theorem. This one is a little more complicated, and it rides the coattails of Rolle's. We couldn't have Rolle's theorem without mean value. I mean, we couldn't have mean value theorem without Rolle's theorem. This one is abbreviated MVT all the time, and you have my in class, on homework, AP exam says that's fine and dandy. They know that MVT means mean value theorem because it's used a lot. Okay? It is kind of like Rolle's theorem, but a little bit more overall encompassing. And it's not as easy to see in your head as this one was. Okay? So let me start writing. Let f be a function that is continuous on the closed interval from A to B and differentiable on the open interval from A to B, period. Give me a minute to catch up with me. Let f be a function that is continuous on the closed interval from A to B and differentiable on the open interval from A to B. How is that like Rolle's theorem? It's exactly the same. Okay, so the criteria here, continuous, differentiable, exactly the same. The only thing is the criteria number 3 does not exist on the mean value theorem. It's only on Rolle's theorem. So from here, we move on. Are you ready? Then there exists at least one C between A and B such that, once you catch up to that, this formula is going to be a little bit longer than the last one. Now in Rolle's theorem, it was just f prime of C equals 0. It's not 0 this time. It's something else. It's f of B minus f of A over B minus A. This has to be memorized. Does that formula look familiar?
Yeah.
Yeah. What is it? It is slope, average rate of change, exactly. It's average rate of change and slope. And it is similar to, The third definition of derivative, if it's got x's in there. F of b minus f of a. Different. This is more difference quotients than anything else. Okay? So, something's coming back to haunt us again. Huh? Here we go. Now, this one doesn't make as much visual sense in your brain as the other one did. Some of you on this other one, once I was done writing the theorem down, you might have been able to mentally picture what they were talking about. This one's not quite so easy. So let's go ahead and draw a picture with this one and show you what we're talking about. I'm going to draw this a little bit bigger because it makes it easier to see. Here's A, here's B. All right. It says that f of A and f of B do not have to be the same. I'm purposely going to not make them the same. Put A down low and B up high. And once again, I need to draw a continuous differentiable curve. And I think for this problem, I think we ought to, unless you've already drawn your points different than mine. Okay? So I'm going to go like this and draw something like that. Okay. I want to look first of all at the right side of this equation. Can somebody tell me graphically what this is really talking about? Say it again.
Kind of like it's just finding the slope of the line that connects A and B.
It is exactly what you said. It is the slope of the line that connects A and B. Because this right here is like y2 minus y1 over x2 minus x1. Does that make sense? So draw in a dotted line that connects A and B. That's what the right side of the equation is talking about. It's talking about the slope of that line. Because it's average rate of change. y2 is f of b minus y1 is f of a over b minus a. That's slope. That's just slope. Basic vanilla slope. Okay? Now, this right here says that somewhere in here on the curve, not on the line, there is a point whose tangent line has the same slope as that red dotted line. Can you see a point on the curve that if I drew a tangent line to it, it would be parallel to this? Can some of you see it? Where does it occur? Like before it crosses or after or both? How many? It's actually both. I see one before. I would say it's about right here, because if you draw a tangent line right there, it's parallel to that one. Do you see that? That's one C value. Is that making sense to you now what I'm talking about? The slope at C is the same as the slope of the line connecting A and B. Do you see another one?
Yeah.
Yeah. I see one right about here. There's my other C. That's what the mean value theorem says. Okay? Now that line's a little bit crooked, but it's getting the point across. Now let me write this in simple English so that when you come back to it in a week or so, you remember what it's saying. So, the slope of the tangent line at C is equal to the slope of the line connecting A and B. The slope of the tangent line at C is equal to the slope of the line connecting A and B. Does that make sense? Simple English? Okay. Can there be more than one C? Yes. Can there be only one C? Now, if I had made these 2 points the same height, and I had connected the 2 points, what would the slope have been? 0, which would have been Rolle's theorem pretty much. Because Rolle's theorem is talking about when the slope is 0. That's why we stagger them, because this talks about the slope for everything else. Okay? How are we doing? I know you're tired, but is this making sense? That's the important thing. Okay, let's do a problem. I had an easy problem on here. I actually purposely made it a little bit harder because I hate it when I noticed that my notes were starting to get much, much easier and the homework was getting harder and it wasn't making a good, parallel between the two. So I'm trying to beef up the notes a little bit. So let's do that. Okay. Now we're going to do mean value theorem without a picture. X plus 3 over x is the function. Show that f satisfies the mean value theorem, MVT, hypothesis, comma, then find all c values on the interval from 1 to 3, period. Show that f satisfies the mean value theorem hypothesis, then find all c values on the interval from 1 to 3. Are we good so far? Okay. Number 1, there's only 2 hypotheses for this one. Not 3, just 2. Continuous and differentiable. Okay? Now, look at that kind of, do you know what kind of graph that is? What kind of graph is that going to be? That is a radiograph. Y'all remember radiographs? Okay? Now, in terms of an equation, a function is continuous if you are allowed to plug in every value for x that you want to. Is there a value that I am not allowed to plug in for x here? Yes. 0. But is the graph continuous? The answer is yes, because the interval is only from 1 to 3. So, since 0 is outside of that, and 0 is the only problem child, then we're good to go. Are you following what I'm saying? So we're going to say, yes, the graph does not exist at 0, but 0 is not on the interval. That's to remind you later why we said yes, even though it's got a denominator. The graph does not exist at 0, but 0 is not on the interval. All right. Differentiable. Okay. That, remember, the differentiable means does the derivative fail? Okay? If I was to take the derivative of this, and I don't want to do it if it's not going to work, what rule would you have to use? Quotient rule. Would it have a denominator when you were done? Yes. What would the denominator be? Okay, what is the problem? The derivative. 0. But 0 is not on the interval. Therefore, is it differentiable? Yes. So check the derivative fails at 0, but 0 is not on the interval. So, as far as mean value theorem is concerned, we are good to go. All right. Now, after you've checked both of these, the first thing I want you to do is to write down the formula. F prime of C equals F of B minus F of A over B minus A. I want to do it in the first period, and I think it's going to make a little more sense. Okay. This left side of the problem means take the derivative. Okay? So, can you take the derivative of this for me? I hope so. So let's do that right now. F prime of x equals, we're going to do low d high. So low is x. What is d high? 1. Minus high. Make sure you put high in a parentheses. D low is 1 again over low squared. Okay, so we clean that up. F prime of x equals x minus 1 times both of those, x minus 3 over x squared. So f prime of x is equal to, those two cross out, negative 3 over x squared. Okay? Now, if we were doing Rolle's theorem, what would we set that equal to? 0. But we're not doing Rolle's theorem. We're doing mean value theorem. What do I set it equal to? you set it equal to f of b minus f of a over b minus a. Now, because a and b are numbers, 1 and 3, I can find out what number that's going to be. Equals what? So we come up here and we do f of b minus f of a over b minus a. And we're going to plug the numbers in. So in this case, it's f of 3 minus f of 1 over 3 minus 1 equals. Okay, remember we're plugging into the original equation, not the derivative. So when you plug 3 into the original, what do you get? You get 2. 3 plus 3 is 6, divided by 3 is 2. Minus, plug in 1 to the original. 1 plus 3 is 4 over 1 is 4 over 2. Am I going too fast? No? 2 minus 4 is negative 2 divided by 2 equals negative 1. Ah, that's what I'm supposed to set it equal to. Every problem with mean value theorem is going to have something different that you set the derivative equal to. Okay? Now, what is this number? It is on the graph, the slope of the dotted line. Now, this one has a positive slope. For this specific, which I don't have a picture of, this is a negative slope. Okay? So this is that line right there. So now, I take this value, come back here, and I say negative 3 over x squared equals negative 1. That's what I set the derivative equal to. And now solve for x, and you're done. How do I solve for x? Multiply both sides by x squared. Negative 3 equals negative x squared. Now what? Divide by negative 1. So 3 equals x squared. Square root of both sides. X equals plus or minus the square root of 3. Okay, I got 2 answers this time. Now, the question is, are they both c values? And in order to be a c value, it has to be on the interval. Which one is not? The negative square root of 3. So my final answer for this is that c is equal to just the positive square root of 3. Any questions? Okay, I went farther in here because I don't think they absorbed a whole lot past this point because they were looking at me very glassy-eyed. I will do the rest of the notes tomorrow. And I'm saying that so that the video people know to go look for a second video on Friday. Okay? I'm going to give you the worksheet. It is part Rolle's theorem, part mean value theorem. It's pretty much what we've been doing here. So if you look at these examples, they will help you do the problems. Okay?